Hi everyone. Is everything okay?
Yes, they will.
Okay. So, hi everyone. My name is K.Newberry, and I'm actually Dr. Bailey's graduate student. And I want to thank you guys for putting up with the camera and for allowing me to present on a topic that I actually work in. So to get things started, just to go over some objectives for today's class. We're going to briefly review the Sperling and the sensory memory set that you guys left off with on Thursday. And then I'm going to get into short-term memory, and so by the end of today you should be able to define what short-term memory is and also describe its duration, its capacity, and how it can be measured. And then towards the end we're going to go over some cool examples of extraordinary memory, sort of applying the short-term memory but in an extraordinary way. Everyone okay with that? Alright, so hopefully this looks familiar. This is the Atkinson and Schifrin modal model of memory. And so you guys started off talking about how information from the environment comes into your senses, and then this first box was sensory memory. And Dr. Bailey, I think left off, does this slide look familiar to you guys? Sperling's experiment? I'm getting a mixed response here. Okay, alright, so can anyone tell me what this experiment was about? Don't all jump at once. Okay, so in this experiment they presented like a matrix of letters, I think, and they asked people to try to recall all of the letters or just like a certain row. Is that ringing some bells? Okay, so basically what this experiment was doing was showing how, like, when you present the whole thing and ask a person to quickly remember all of those letters, they can't do it. And that's because sensory memory, like, it has this large capacity but this really short duration. But if you can pinpoint certain aspects of the matrix, so if you guide them towards a certain row, they're able to remember more of the letters. And so what this experiment was showing was that basically you have this decrease in performance due to the rapid decay of something called iconic memory. And so iconic memory is your sensory memory for visual stimuli, and it decays within about 1 second. And so this is what we saw with the Sperling experiment. But there's also echoic memory, which is just the sensory memory for auditory stimuli. And this type of memory actually lasts ever so slightly longer than your visual memory, so it decays after a few seconds. And so have you guys ever been in a situation where you're trying to talk to someone, but you know that they're not listening to you, but because you try to catch them if they're listening or not, you ask them to repeat like what you just said, and they're able to do it even though you know that they weren't listening, and it's really frustrating because you want to catch them. That's actually because the auditory stimuli it lasts a couple seconds longer than visual memory. And so if you actually wait like 5 to 10 seconds and then ask that person to try to catch them if they're not listening, you'll be more likely to catch them because that information will have left their sensory memory and they won't be able to just repeat the words back to you. Do you guys have any questions about iconic memory or echoic memory? Okay. So now I'm just going to briefly recap. So sensory memory has large capacity, and this is due to everything being received from the environment by our receptors, but it has a very short duration. And then why was Sperling's experiment important? It revealed that large capacity, short duration, but it also showed how fast these cognitive processes can occur and how we can be unaware of those processes happening. And so if you guys are okay with that, I'm going to move on to short-term memory. Is that okay? Great. So I don't know if you guys can see it in the back, but I have a little comic of a goldfish because, I don't know, there's this thing that goldfish have really short memories. And so it starts off with like, oh wow, I got it. And then there's this elaborate equation of the meaning of life. And then the tragedy of a 3-second memory. What was I thinking about? It's supposed to be funny. All right, so the second box of the modal model is short-term memory. So you have the information from the environment coming into your sensory memory, and then you attend to that information. That's what that first arrow is. And the information that you're attending to from your sensory memory ends up into short-term memory. And so short-term memory holds a limited amount of information for a brief period of time. And it includes new information from sensory memory as well as information from long-term memory. And that's the point of the bidirectional arrows there. So in this example at the top, the girl is receiving the sensory memory, or the sensory information from the computer, it's visual information, but then she focuses on these numbers, which is a phone number. And so what she's focusing on is what's going to be in her short-term memory. Does that concept make sense to everyone? And so, what do you guys think the duration of short-term memory is?
8 to 10 seconds.
Okay, it's within the range. Anyone else have any other guesses? Okay, we're kind of sleepy today. So the duration of short-term memory is 15 to 20 seconds. And to illustrate this, I'd like to do a quick demo. So, would anyone like to volunteer? Someone volunteer. I will pick on you if you don't volunteer. Thank you. Okay, so I'm going to say some letters, and then I'm going to say a number. Your goal is to remember what the letters were. However, as soon as I say that number, you're going to repeat it out loud. And then you're going to count backwards out loud by freeze until I say recall.
All right.
Is that okay?
I'll go for it.
Are you ready? Okay. F, Z, L, 332.
332, 329, 326, 323, 320, 317, 314, 311, 308, 305, 306.
Recall.
F, Z, L.
Okay. Are you ready for trial 2? Okay. B, H, M, 87.
87, 84, 83, 78, 75, 72, keep getting hung up, 69, 66, 63, 60, 57,
Recall.
B, H, L.
I couldn't even remember. That was close.
Okay.
Okay, one more. X, C, G, 306.
306, 303, 300, 297, 294, 291, 288, 285, 282, 279, 276, 273, 270.
Recall.
I say there's a G and an L in there.
There was a G. It was XCG. So how difficult was that? Or yeah, round of applause.
Pretty difficult.
Yeah, and it got harder with each trial, right? So in 1959, Peterson and Peterson used this method to determine the duration of short-term memory. And so they would say 3 letters and then a number, and then the participants had to repeat what the number was and then count backwards by freeze. And they varied the amount of time between when they had to start counting backwards by freeze and when recall was. And so in some situations, they had participants only wait like 3 seconds. So in our example, if I had stopped him after he did like 1 or 2 of the backwards numbers and then had him recall, it'd probably be a lot easier to remember those numbers multiple times than if we were to wait longer. And so when they had participants just wait 3 seconds, recall was approximately 80% of those 3-letter groups. And that just means that if you did that 10 times, 8 of those trials would be remembered. So 8 of those 3-letter groups. They also varied the waiting time to 18 seconds. And you can see that recall dropped to 12% of those 3-letter groups. And that's something that we actually started to see in our own example right here. It became more and more difficult to remember what those letters were. And so, why do you think it became harder to remember what those 3-letter groups were? Any ideas? Yeah.
Because as you're starting the count, you're probably repeating the letters in your head, but then as you start concentrating on the numbers, you just forget to keep saying them in your head.
Alright, great. So you're not able to rehearse the letters that you're supposed to be remembering because you have to count backwards by 3s. Is there anything else that was happening?
Is it because you're getting closer to your max on your short term? 80 seconds is kind of closer to 20 seconds?
Yeah, and so I guess that alludes to the passage of time. And so the longer you have to wait, the more time there is for that information to kind of just dissipate. And so this leads to decay and interference, which is what's going on in this experiment, and which is why that information gets lost after approximately 20 seconds. So why is information lost from short-term memory? Decay is when information falls apart with the passage of time. So, like the student in the front here said, sorry, I don't know your guys' names, you didn't have time to rehearse the information. And so generally, almost all the information in short-term memory is lost after 20 seconds if you're not able to rehearse that information. In addition to decay, there's also interference. So other information kind of bumps the original information out of short-term memory. And so we saw this in our experiment where we started going through multiple trials, and then there was the introduction of new letters and new numbers, and so that information made it more difficult because it created more interference. You guys able to get all of this down? Okay, so to make your lives more difficult, there are actually 2 different types of interference. The first type is called retroactive interference, and this is when learning new information interferes with the recall of previously learned information. And so as an example, say that you're trying to remember the Spanish word for dog because you took Spanish in high school, but now that you're taking this new French class in college, because you just learned the French word for dog, you can no longer remember what the Spanish word for dog was. And then proactive interference is when old information interferes with new information. So your previously learned information interferes with the learning of new information. And an example of that is when, so say that you already learned how to ski and you're trying to learn how to snowboard. It's more difficult to learn how to snowboard because you previously learned how to ski. And so these can get a little bit tricky. I know sometimes I forget which one is which, but do these concepts make sense to everyone? Which of these types of interference was going on in the Peterson experiment?
Retroactive.
Mm-hmm.
The retroactive, because technically the number is new compared to the letters in time, at least.
Kind It's actually proactive interference because the previously learned information is interfering with the learning of the new information. And so remember that in our class example, the first trial, he was able to get all of those letters. That's because he hadn't done it before. And so when he was trying to remember those new letters in the newer trials, that old information that he had already remembered was interfering with the new information. Yes?
Did you guys hear him say L on the second trial? Because there was an L on the first trial. So that old information was getting in the way, and he was actually making that mistake. Because we weren't Plaza County, so we may notice that. But did you guys see that? So where that original information was affecting his memory for the new information.
Yeah, so no, thank you for that. That's just a concrete example of illustrating the proactive interference. Good, there's a lot on that slide. Alright, so in addition to the duration of short-term memory, there's also the capacity component of short-term memory. And the capacity of short-term memory is 7 plus or minus 2 based on George Miller's magical number 7. So a while back, this guy wrote this really long paper about how everything revolves around the number 7. And we actually find that when we measure the capacity of short-term memory, most people fall within the 7 plus or minus 2 range. And so we can measure short-term memory capacity by using something called digit span, and this is just how many digits a person can remember. So I'd like everyone to put down all your pens and pencils. Okay, we're going to see what our digit spans are like. And so up on the screen, there's going to be a series of numbers, and they're going to be presented one at a time. I'd like you guys to try to, remember what they are, and then when you're prompted to write them down, then see if you can recall them. Does that make sense? Are we all ready? Ready? Everyone have their answers down? How'd you guys do? Anyone get the first one right? Raise your hand. Number 2? Number 3? Oh, there we go. Okay. So it got a lot harder when there were more numbers to remember. So this illustrates that the typical result is 5 to 8 items. So most of you were able to remember like the first trial when there were only 4 digits, and then the second trial when there were 6 digits, but when it became 10, it became much more difficult. But this gets us into the question of what exactly is an item. So we've been talking about these digits and how we can only remember about like 5 to 9 digits in our short-term memory, but what does that actually mean? So the capacity limit of 7 plus or minus 2 for short-term memory applies to stimuli that are unrelated. And so if I give you these 7 different words, pen, soda, belt, bee, walk, rain, silly, it's going to be harder to remember all of these words versus she went shopping for a new coat. It's still 7 different words, but because you apply meaning to those words, those 7 words now become one sentence unit. And one sentence unit is easier to remember than 7 unrelated words. Does that make sense? And so what this is illustrating right here is actually a concept called chunking, where a chunk is a larger unit of information that's built out of related smaller units. And so in trial 3, if we were to take these numbers and actually chunk them, they become a phone number. Much easier to remember than trying to remember 10 different digits. Does this concept make sense to everyone? Okay. Just to illustrate it further, another example, changing it up, there will be letters this time, not numbers. Right, so pens down. Ready? Good? All right. Which one of these was easier?
Yeah,
Did you guys catch on to the chunking? Okay, so yeah, in trial 1, it's just a bunch of random letters, but once you can apply some meaning to it, it becomes 3 separate chunks. So this kind of leads into sort of the last portion of my part of today's lecture. And this leads into extraordinary memory. And so there was a study in 1989 by Erickson et al., and he actually trained a college student to use chunking, so use that strategy that we just applied. And this person just had a normal digit span. They could remember 7 digits just like any other person. But after 230 one-hour training sessions, the student could now remember up to 79 digits. And he did this by learning to chunk the digits into meaningful units. And because he was a runner, he used running times. And so as an example, if he wanted to remember 6192, he would put it into a time format that you would hear at like a track or a meet or something like that. And so 6192 became 6 minutes and 19.2 seconds. And using that strategy, he was able to get up to 79 digits. So I think that's a really cool example because I can tell you right now I could not do that. So yeah, it's actually something that you can take, and if you practice it over and over and over again, you can be able to do something like that. But it takes a lot of effort and training. And so to kind of bring this concept back to home, we actually, not a few years ago, more like 20 to 30 years ago, we actually had a cognitive psychology faculty member who was studying short-term memory, Dr. Charles Thompson, and there was a grad student at Kansas State. And he had this like extraordinary memory. He was for digits specifically, and so he's able to remember a lot of digits of pi. And I want to see, can you guys guess how many digits of pi this kid could remember?
A few hundred, isn't it?
Huh?
It's a few hundred, isn't it?
A few hundred? Higher.
A few thousand.
Higher.
30,000?
Huh?
30,000?
Yeah. He could remember over 31,000 digits of pi. So I don't know about you guys, but I think that that is really incredible. And I think it's also really incredible that that research is actually done right here at K-State. So I don't know if any of you guys were familiar with Dr. Freeman. He recently retired, but he was a faculty member here. And he and Dr. Thompson and another faculty member, I don't know if he was at K-State or not, actually wrote a book about memory, and it included all of the research that they did with this student who went here at K-State. Okay, so I actually want to apply this to you guys. So how many digits can you guys remember right now of pi?
3.141592652897.
All right, you're pretty, okay, we've got one that can do a lot. So when I was first introduced to psychology, I took an AP psychology course in high school, and the teacher at the time, when we were covering this, he gave us this story to remember to help us learn the first 20 digits of pi, and I would like to share that with you because I think it's a good example of showing how chunking can be a useful strategy. I don't know why you would need to know the first 20 digits of pi if you just want to be more accurate in your math calculations, I don't know. But essentially, okay, I want to see if I can actually do this. So, is it easier for you guys to see over here or over there? I'm going to use the board. Does it not matter? No. So, I know that it's broken up by age, drinking, and basketball. So those are our three bigger chunks. And so I think the story starts off with like, there's 3 people sitting around a table. One of them is 14 years old, one of them is 15 years old, and the other person is 92. And then there's a 6-pack of an unspecified beverage on the table with 5 left. And one of the people thinks that they can drink 3. The next person thinks that they can drink 5. And that would total up to 8. And those people are watching a basketball game, and the score is 97-93 with 2 minutes and 38 seconds left. And then it's a close 4-point game. And if anyone wants to check if they have a laptop or not, are those the first 20 digits of pi? Maybe.
It's like the first 16 I know.
Okay. So, yeah, so I don't know, that really resonated with me. I thought it was an excellent example of how you can use chunking as a strategy for short-term memory. And a decade later, I'm now able to remember the first 20 digits of pi. And so if you really want that story or want me to write it down for you, I can give it to you if you want it. But I thought it was pretty cool. And if you practice enough, you can compete in the Memory Olympics. Have you guys ever heard of the Memory Olympics? No? It's an actual thing. Okay, so I'm going to go to a website, so just bear with me for 1 second. Or my computer's going to freeze up. It's always great too. Oh, real quick, the research that was done at Kansas State on the extraordinary memory, I think that guy, I don't know if he still holds the Guinness World Record for the most digits of pi, but it was a world record at one point. And you can find articles online, like in Tulsa World, that still talk about that kind of stuff. But This is one of the people who competes in the Memory Olympics. And it's like a world tournament. There's people from America and Germany and Sweden. I think this guy's from Sweden. And what does it say? He became the world memory champion in 2013 after less than 18 months of training. Yeah. And so they do all different types of tasks, so remembering letters and digits and decks of cards and faces and stuff like that. And so, let's see. There's a video I would like to share with you. It's not in English, but I don't think it needs to be in English for you to get the point. So this guy can memorize a deck of cards while riding a roller coaster. I don't know about you guys, but I would never in a million years be able to do something like that. And so I thought it'd be cool to share this. So who's feeling inspired? Who's going to do that? Yeah. So, I don't know. I just thought those were really good illustrations of what you can do if you actually apply these types of strategies and try to train your short-term memory. So I'm going to end with just a quick review. So, what's the duration of short-term memory? Yep, 15 to 20 seconds. How is information lost? Interference and then what are the two types of interference? Good. What's the capacity of short-term memory? What strategy can you use to increase this capacity? What are the first 20 digits of pi?
7, 9, 3, 2, 8, 5, 6. That's close.
You're close.
That's close.
All right, that's all I have for you guys. Thank you for your time. And if you have any questions about this information or want to talk to me about it at any time, I can get you my contact information.